Test the series for convergence or divergence. We have the summation n equals 1 to infinity, n over n plus 1. The whole thing is raised to the n squared power. Whenever you notice that the terms in the sequence are raised to the nth power, then it's good to use the ratio test. The root test. This is to the n squared power. Let's see what happens. With the root test, we have to do the nth root of the absolute value of the a sub n's, and do the limit as n goes to infinity. The nth root of the absolute value of the a sub n's. Okay, so that's going to be as n goes to infinity. Well, if we already have the a sub n's is this, to the n squared power, the nth root is raising to the 1 over n power. Right? And so, and technically there's absolute values there, but we always have positive terms, so we can kind of ignore that at that point. And what's going to happen then is that's going to take away one of the n powers in the exponent, and that's going to leave us with just instead of being to the n squared power, we're going to have n over n plus 1 to the nth power, right? Because n squared, you can multiply the exponents together. We can cancel out one of those n's from the n squared. Great. So that's going to be your new exponent n, and it's our job to figure out what this limit is. If it's less than 1, we get convergence. If it is greater than 1 and still a constant, we get divergence. If it's infinite, we get divergence. And if it's equal to 1, then we say that the the root test is inconclusive. We've seen something very similar to this. We've seen n plus 1 over n raised to the n. And we're going to use that idea then to rewrite this guy. This is the limit as n goes to infinity, the reciprocal of that guy. N plus 1 to the n. Let's write it as n plus 1 to the n. If we flip the n side, then what we have to do is put a negative on the exponent. And what that means is anytime you have a negative exponent, that's 1 over the positive exponent. And the reason why we're doing all this is because we know what n plus 1 to the n is as a limit. It'll be more recognizable if we divide both terms by n. So we have limit as n goes to infinity, 1 over, and then rewrite this guy to be 1 plus 1 over n, and the whole thing is raised to the nth power. And hopefully we recognize the denominator limit. We have shown in class that the limit as n goes to infinity of 1 plus 1 over n, all raised to the nth power, we've shown that that is equal to e. And some people actually use that as a definition of e. And so then what we have is simply 1 over e. That's what our limit is. That is less than 1. So by the root test, the root test shows that we have a convergent series when the limit is less than 1. The root test is going to give us that we have a convergent series. I'll go ahead and rewrite what it is. N over n plus 1 to the n squared from 1 to infinity is a convergent series. By the root test. Very good.